Hey everyone! So since we're in the section for oligopoly, I thought it'd be a good idea to cover a little bit of game theory. Um, so what I've done is try and distill down the essential steps to solving a game. And this works with the games that we've seen in the book, but also should work for all different types of games you might see as you continue throughout your econ career. Um, so I've really tried to break it down and keep it simple because this is not necessarily the most simple process. Um, so what we're going to look at is an oligopoly game. It's very similar to and I mean it is quite similar structurally to the classic Prisoner's Dilemma. And I'm going to show you how to solve it. And again, this should work with any type of game that fits into a matrix like this guy. So let's do this. So step one is build the matrix. So any type of game that you can fit into a matrix is going to have players, strategies, and payoffs. So in this game where we have the four different cells, what we have are two players, two strategies, and different payoffs for each one of the situations we might run into. So what are we doing here? Well, what we're doing is we are trying to organize strategic behavior, right? So our players in this game are AB InBev and SAB Miller, and we always put player one over here, their strategies right here, and then their payoffs always go on the left-hand side. And I put them in different colors. So player one in this game is in red. And then we always have player two, who is SAB Miller, up here. Player two's payoffs go on the right-hand side of each cell. And each one of these cells represents a different outcome you could think about, a different world maybe, where in this world we have both competing. In this world we have both colluding. And in this world here, we have that AB InBev is competing and SAB Miller is colluding. So you should be able to grab those payoffs. Either they'll be given to you, or you might have to actually fill in these cells. So an example of a setup you might get is that the problem will say, if the firm is competing while the other is colluding, then they are going to make $60 in profit. So therefore I was able to populate that cell. Because you'll notice that I didn't say which firm, because actually we can go from SAB Miller from player two's perspective to in the blue. And I've used that same line to fill in this cell, where if a firm is competing while the other is colluding, they are making $60. And I just saw a little typo here, or righto. Let me fix that really quickly. Okay, so anyways, continuing onward. So now that we have our matrix built, we can actually go through the strategic decision making that oligopolistic firms are making. So our example is with AB InBev and SAB Miller. They are the dominant firms in the global beer market. Together, they take up almost 30% of the market, which is a huge chunk, and also most of the other firms in that market are taking up way much smaller slices. So it's a pretty good example of strategic decision making, because their pricing choices are going to affect the other person's payoffs, or other person's profits, and that's what strategic decision making is all about. That's what game theory is all about, which leads us to step two. So what we're going to actually do is kind of put ourselves into the brain or maybe to the boardroom of each of the players. So we start with player 1. So we're going to focus on the columns. So I'm going to start with column 1, and I'm going to focus on player 1's payoffs. So essentially what I'm doing is I'm saying if I were AB InBev, and I'm looking at a world in which SAB Miller is competing, would I do better if I compete as well, or if I collude? And what you can see clearly is that I'm going to do better off. I'm going to make $40 if I compete. So I'm going to go ahead and underline that payoff. Cool? Awesome. Just to reiterate, what they're saying is that if SAB Miller competes, I'm better off competing too. And then we move to column 2. Again, looking at these red payoffs. Now they're saying, if SAB Miller colludes, would I be better off competing or would I be better off colluding? And what I'm going to see clearly is that I'm going to be better off competing. So I underline that payoff. So now I have each of the best choices that AB InBev can make given both the strategies that SAB Miller might make. So now I have their best responses. And step 3 is simply doing the same for player 2. We're just going to change the notation a little bit. So player 2, we're going to focus on the blue, the values on the right-hand side, and we're going to look at the rows. So player 2 is saying, if AB InBev is competing, should I compete or should I collude? And they're going to determine that they get a higher profit if they compete. And for player 2, we're going to do an overscore or an overliner. I don't know that there's a word for that. I sure as heck don't know what it is. So, best response to the other player competing is to compete. Cool? And then again, we're going to look at row 2, player 2's payoffs. If player 1 colludes, am I better off competing or colluding? And we're going to see that I'm better off competing. So now I also have player 2's best responses in each possible situation marked. And then step 4 is pretty straightforward because the definition of a Nash equilibrium is an equilibrium in which both players are choosing their best responses to the other's actions. And we can see that the only scenario in which both are choosing best responses is here at compete, compete. So with this nice little notation where you have the underline and the over score, you clearly see the Nash equilibrium where there is any situation in which there is an underline and an over score. I tend to circle my Nash equilibrium, but you can also, the correct notation to write out the Nash equilibrium is by putting the player 1's Nash equilibrium strategy and player 2's Nash equilibrium strategy into parentheses with a comma separated. And that's kind of how it works. I hope that this helps you. It's definitely the most distilled, simplified way that I've learned to work with different types of games and strategic behavior between firms, people, and even in international, you can do this with countries making decisions. So it's a pretty useful tool. I hope that you guys enjoy this because I think it's one of the coolest parts of microeconomics. Bye.